if a constant force F, notice we have this arrow on top, meaning it's a vector, right? Thing not plugged in. There we go. We have this arrow up top, so the force is a vector, displaces an object of amount represented by D, it does work on the object. D is also a vector. So D is displacement, really, like kind of like distance traveled, but we're making it a vector, right? And F is a constant force on an object. Doesn't matter what direction, just a constant force. The amount of work is given by W equals F, not times. It is kind of times, but we called it something else for vectors. Does anyone remember? Maybe I can give a little participation check. Dot. Great job, Colton. I always forget to look. Oh, man. I'm just talking. There we go. F dot D. Oh, I see a bunch of chats popping up. Dot product, yep. Probably be easier telling me yourself for the points when online. Just pro tip. But yep, so that's going to be F dot D. So these are two vectors that we're multiplying together. And notice, hey, this W doesn't have a vector on top of it, right? And remember when we did the dot product, I said it doesn't spit out another vector, it spits out a scalar. The only multiplication, I don't want to call it multiplication because it's really not, but it's kind of, that spits out another vector is the cross product. But the dot product just spits out a number. So Alvaro works for a package delivery service. Suppose he is pushing a cart full of packages weighing 100 pounds up a ramp 8 feet long at an incline of 25 degrees. Find the work done by gravity as the cart moves the length of the ramp. Assume that friction is not a factor. Now, I'll give a participation point for this one as well. What do you think the first thing I want to do is? Any of these problems? Start with a triangle. Close. I think you're trying to say draw a picture, right? Draw a picture of the dang thing. So, suppose he is pushing a cart full of packages, 100 pounds. So ramp 8 feet long. So we have a ramp that's 8 feet long, and we have an incline. So maybe I'll do a. Well, I guess the ramp would have to be built on solid ground, yeah. So we can. I'm just gonna make a way better ramp here, right? So okay. Good enough. Kind of hard on a tablet. 25 degrees. And this ramp is 8 feet long. All right, and then however tall it is. But yes, right triangles are friends. And he's pushing this package up, and it's 100 pounds. Now, this is the part where I kind of just have to give something to you, right? So if we're finding work done, we know we're going to have two vectors here, the constant force and the displacement. Now, when I'm doing a dot product, remember, I did a dot product when I had vectors and their component parts, right? And so I'm going to find my X and Y components here, right? To find X, right, this is where we need to do some right triangle trig. We have 25 degrees and we have adjacent hypotenuse. So that's going to be the cosine of 25 degrees equals adjacent over hypotenuse. Multiply the 8 over, I'm going to get X equals 8 times cosine of 25 degrees. Let me make sure I'm in degrees here. I am 7.25 rounding And now y, if I do y, we're going to need opposite and hypotenuse, or the sine of 25 degrees equals opposite over hypotenuse, multiply the 8 over. And we get y equals 8 times the sine of 25, 3.38. So my vector is 7.25, 3.38. Oh, hey, by the way, guys, I'm looking at a lot of your homeworks. If I see one more parenthesis for vectors, I might scream louder than I already do sometimes. They're not parentheses, they're like little, they're straight, kind of. 7.25, 3.38 to denote a vector. If you do this, maybe it's just bad handwriting. But if you do this, that's a point. This isn't a point, this is a vector. Don't do this. Bad. Okay. So that's one vector. Can you guys tell me whether that is F or D? I'll go back up. F is a constant force. D is displacement. What did I find here? Constant. Is this constant force or displacement of this box? Ab's got it. That's displacement. Right. So, and that's because this triangle is where it's moved, right? It's pushed 8 feet up this ramp. Yeah. It's moved 8 feet up this ramp. And so that's the displacement. The distance it's covered was this x component and this y component. So that would be the displacement. Now, okay, what the heck is F then? This constant force. And I kind of hate how our pre-calc book does it. I always ask how many people are in physics in here, but I can't get hands this time, but I think a good amount of us are in physics or AP physics. When you guys deal with forces, I don't know, or can someone answer me real quick? Has physics or AP physics dealt with like free body diagrams and forces and statics yet or anything? Or you have? Okay. And you guys usually work with newtons, right? The book just leaves it in pounds all the time. Like they consider the force to just be the weight. So here's my, especially for you physics people who probably have done a lot of work with newtons, I imagine. I don't know what goes on in your physics classes, but I imagine you deal mostly in newtons for forces. For pre-calculus, this is the time to hone in. For pre-calculus, your forces can just be considered like in terms of pounds, right? So if this is 100 pounds, gravity, right, because it wants the work done by gravity, gravity goes straight down, right? Even though this is on the ramp, gravity pulls straight down. And so the force is going to be 0 in the x direction, or I should make this green again, right? 0 in the x direction, because this force of gravity doesn't go left or right, it only goes straight down, and it's going going to go down by, we can label it by 100 pounds. So 100, or negative 100, right? Negative 100, because we want the forces pulling down. Usually we consider alt positive, down negative, right? So we need to make sure we have our negative in there. So our force is 0, negative 100. And again, the way to distinguish those things is the constant force you have acting upon it is gravity, the weight down, right? That's constant while you move it up that 8 feet of ramp. And so when you do these, a lot of the time the weight is just going to be your constant force. You could have maybe a constant force pushing it in an X direction, or maybe somehow in an X and Y direction. Just make sure it's a constant force, right? And of course, gravity is a constant force, always acting. And then again, I also think just recognizing the displacement being where has the object gone in terms of X and Y, right? If it's gone up this ramp 8 feet, it's gone this far to the X, this far and Y. I think that's, and then once you have displacement, I think finding what vector the force might be easier, right? As long as you know, if you can do the first one and you find which one it is, then it's probably easier to look out for the second one. Well, now we just do the dot product, F dot D. So let's do that. F dot D equals 0, negative 100 dot 7.25, 3.38. And that's going to equal 0 times 7.25 washed plus negative 100 times 3.38. So negative 338. And then I guess there's the unit would be foot pounds. Doesn't really matter that much. If you get negative 338, I'll be happy. So, oh, and hey, problem's done. Negative 338 is good. That is the work done on the object. But